Hello students, today we are going to see triple integration. In triple integrations, there are three variables x, y and z, and you can see that this triple integration of function x, y, z, dx, dy, dz. Application of triple integration is, you can say, to find out volume, or we can find out center of gravity, moment of inertia or mass in three dimensions. So this volume is given by v is equal to triple integration of dx into dy into dz. Now one function of x, y, z variables is given to you, and over this region, over this volume v, we are going to find this triple integration of that function into dx, dy, dz. Now whenever x square plus y square plus z square equal to r square, that means the sphere is given to you, we have to take the spherical polar coordinates. So see the relation x, y, z in terms of r, theta and phi. So this r, theta and phi, they are spherical polar coordinates. X is equal to r sin theta into cos phi, y is equal to r sin theta into sin phi, and z is equal to r cos theta. So this represents spherical polar coordinates. X square plus y square, if you take, so squaring and adding this 2, it will give you r square sin square theta cos square phi. So squaring of this equation plus r square sin square theta into sin square phi, which will give you r square sin square theta. Inside the bracket you will have cos square phi plus sin square phi, which is 1, and therefore x square plus y square is equal to r square sin square theta. If you combine this x square plus y square plus z square, so the resultant will be r square sin square theta plus r square cos square theta. So that will give you r square, and this x square plus y square plus z square equal to r square is nothing but a sphere with center at 0, 0, 0 and radius r. By using Jacobian, we can prove that dx, dy, dz is equal to r square sin theta dr, d theta, d phi. Now in the same way, there is cylindrical coordinates. Whenever equation of cylinder is given to you, so we have to go with the cylindrical coordinates. They are rho, phi and z. X is equal to rho cos phi, y is equal to rho sin phi. The resultant will be x square plus y square will be rho square, and we have to take z as z variable. So you can see this cylinder where this surface is a circle and this surface is again a circle, which is x square plus y square is equal to rho square. Now this is all about spherical and cylindrical coordinates. Now whenever ellipsoid equation is given to you, x square by a square plus y square by b square plus z square by c square is equal to r square, x is equal to a into r sin theta cos phi, y is equal to b into r sin theta sin phi, and z is equal to c into r cos theta. Just if we are going to multiply the spherical coordinates, means x is equal to multiply this side by a, y is equal to multiply this side by b, and z is equal to this side into c. So we'll get this coordinates for this ellipsoid, so that this equation will get satisfied, and dx, dy, dz will be abc into r square sin theta dr, d theta, d phi. Again, by using Jacobian concept, we can prove this relation for ellipsoid. Now in the example, they will give you the region where complete sphere or maybe hemisphere or maybe octant part of the sphere is considered. So accordingly, we will see the limits. So when we consider a complete sphere, now see this, there are spherical coordinates. We know that the coordinates are r, theta and phi. Now for a complete sphere, let's fix this theta. So theta is equal to 0. If you count, if you measure this theta, this is theta equal to 0, then this line will be theta equal to pi by 2, and this will be theta equal to pi. So theta axis we have to fix, and over this theta axis we are going to rotate the circle to form a sphere. So you can see the rotation is phi, which is from 0 to 2 pi. We are going to take a complete rotation. So phi limits will be 0 to 2 pi. Theta limits will be, since we have fix this line. So theta limits are 0 to pi. Phi limits for a complete rotation, we are taking 0 to 2 pi, and radius, of course, it is 0 to given value a. So for a complete sphere, x square plus y square plus z square equal to a square, limit for r 0 to a, limit for theta 0 to pi, and limit for phi for complete rotation 0 to 2 pi. Now hemisphere means half part of a sphere. So half part, that means we are going to cut this sphere along this line. So half part of sphere we are going to consider, that means theta will be from 0 to pi by 2. R will be 0 to a, R will remain as it is 0 to a. Theta, we are going to cut the axis theta. So 0 to pi by 2 are the limits for theta. And phi, in the hemisphere also we are going to take the complete rotation. So phi limits will be 0 to 2 pi. Now for a octant means actually 1/8 part of a sphere. That means we are going to cut this hemisphere 2 times. So 2 times we are going to cut this hemisphere. So now theta axis will remain as it is, but we are going to cut this hemisphere along this direction, along phi 2 times. So 0 to pi and 0 to pi by 2. That means phi will be from 0 to pi by 2. Since it is 1/8 part, we are going to cut a sphere into 8 equal parts, or we are going to cut this hemisphere 2 times. So phi limits will be 0 to pi by 2. Theta limits will be 0 to pi by 2, and r limits will be 0 to a. This is the limits for octant. Now let's see one example. Now here limits are given to you. So triple integration of x plus y plus z dx dy dz, x minus z to x plus z, 0 to z, and minus 1 to 1. Now as that of double integration, we have to recognize that order of integration. So here function of x and z is given as a limit. So this must be limit of y. So y equal to x minus z, x plus z. Now second, 0 to z. So this is function of z, that must be function of, that must be limit of x, because y variable we have done with this y variable. So only limits, only variables are x and z. So this is function of z, implies this must be a limit for x. So x equal to 0 to z and z equal to minus 1 to 1. So order of integration is very important. X minus z to x plus z, they are functions of x and z. So they are limits for y. So y is done. So remaining variables are x and z. So this is function of z, must be limit for x, and the only variable we left with is z. So z equal to minus 1 to 1. So this is order of integration. First you have to integrate with respect to y, then with respect to x, and then with respect to z. So y equal to integration of x minus z, x plus z of the function x plus z plus y. So I have taken this x plus z in one bracket because with respect to y we are going to integrate. So this must be constant term. X plus z is constant, and plus y. So you can see the integration of x plus z is y times x plus z, plus integration of y is y square by 2, within the limit x minus z to x plus z. So putting upper and lower limit, you can simplify this term. Upper limit is x plus z, so x plus z into x plus z plus x plus z bracket square by 2, minus lower limit is x minus z, so put this value y equal to x minus z into x plus z, and minus of x minus z square by 2 times dx into dz. So I have simplified this function, and the resultant you are getting is 2z square plus 4zx into dx. Now we are going to integrate this with respect to x. So you can see this 2z square, integration of this 2z square with respect to x is 2z square x, and integration of 4zx is 4zx square by 2, within the limit x equal to 0 to z. So upper limit minus lower limit will give us 2z square into z which is upper limit, that means 2z cube plus this 2 and z cube plus 2z cube minus x is equal to 0. So after putting lower limit you will get the 0 value 0. That means you will left with 4z cube as a integral. So 4z cube, integration of 4z cube within the limit -1 to 1. So that integration, this is a single integration now. So I is equal to integration z is equal to -1 to 1 4z cube into dz, and which will give you integration is equal to 0. So answer for this example is 0.